the average rate of change of a function. In the real world, there are functions that are not straight lines, but do have a rate of change happening among them. If you notice this particular function, it is not a straight line. However, between two specific points on this function, you can find the average rate of change by finding the slope of the line that contains the 2 points. This line is called the secant line. So looking at my graph, I have 1 point that is 1357. That means that at age 13, this particular young man was 57 inches tall. And by the age of 18, he was 76 inches tall. So we can actually use these 2 points to find the average rate of change between 13 years old and 18 years old for his growth. And remember, it's not just rise over run, it is the change in y over the change in x. So again, I label my points as x1 and y1, x2 and y2, and by subtracting 76 and 57 and 18 and 13, I get 19 over 5. So the slope of this particular young man is 3 4/8 or 3.8 inches per year. We can use this information and the formula to find the average rate of change of any function. If you recall, in an actual function, we refer to the points as x and f of x. So therefore, the first number that you are given, your x1, you will plug in and get a value for your f of x. With the second value of your x second, you plug that in value into the function and you get your f of x2. Subtract the answers of f of x of 2 minus f of x of 1 over your original x values, x2 minus x1, and that ratio will go ahead and give you your average rate of change of the function, aka your slope. Let's look at an example. Finding the average rate of change. So I'm going to go ahead and do part A in one format, and I will do part B in a different format so that you can feel more familiar with it. In part A, I'm going to first find the value of f of x1 and then f of x2, and then I will find the slope. So f of 0, which is my x1, is going to be 0 squared. So f of 0 is just 0. Now I'm going to plug in the x2 value of 1. So f of 1 is 1 squared, and f of 1 is positive 1. So what this happens is that at 0, I have a value of 0. And at 1, I have a value of 1. Where did I get these 2 points? Well, my x1 was 0, and then I solved for it, and I got a 0. My x2 was 1, and then I solved for it, and I got 1. So now that I have my 2 points, I can find my average rate of change. M equals y2 minus y1 over x2 minus x1. And like always, I label my points x1, y1, x2, y2. So I end up with 1 minus 0 over 1 minus 0. And again, if it's easier for you to cross it out, please do so. This gives me 1 over 1, which reduces to just 1. So my slope is 1. Now, for part B, I'm going to go ahead and do it slightly different so that you can see the difference between just writing it as slope and writing it as the actual average rate of change. By writing it as the actual rate of change, m equals f of x2 minus f of x1 all over x2 minus x1. So instead of me doing the functions first and then plugging it in, you actually do the functions within the problem. So my f of 2 is 2, and I'm going to take the square of it. So I'm going to go ahead and do 2 squared minus my f of 1. So I'm going to do 1 squared all over 2 minus 1. Just plugging in the x values. Two squared is 4 minus 1 squared, which is 1, all over, sorry, and zoomed out, all over 2 minus 1. So I end up with 3 over 1, which gives me 3. And that's my answer. I want you to go ahead and try part C on your own in whichever format you